Right, first question. Take given information here, it's travelling on a horizontal road, passes a time t is 0, constant velocity of 18, it continues travelling at this velocity for 48 seconds, it then decelerates for the next 12 to pass the point B. Sketch a velocity time graph. Now then, the velocity time graph, firstly you have to label the axis clearly, time with units of seconds there, horizontally, velocity, meters per second, going up, right? So if you haven't got those labels there, you're going to lose the first mark, right? It has to be clearly labelled. Now then, it's starting with velocity of 18, and it does this for 48 seconds. So 0 seconds is there. It then decelerates at a constant rate for the next 12 seconds until it passes a point B with the velocity of 3 meters per second. So I'm travelling for another 12 seconds, so it has to go to 60, and it's when it gets to this point here, it's then travelling with the speed of 3. So your velocity time graph looks like that. The only numbers you put on the axes are the key numbers where it's changing direction. So it's not a graph, those are the only values you want on there. Okay, and that will give you the 2 marks. Then part B, find the magnitude of the deceleration of the vehicle. Well, it's decelerating at this stage here. Then I can do it 2 ways. I can either use the equations of motion, or I can use the gradient of that slope. Alright, I'm going to do it by the gradient. So I make my right angle triangle, and this length is 18 take away 3, which is 15, and this value is 12. So the gradient is 15 over 12. It's a negative gradient, so it's minus 15 over 12. That comes to minus 1 1/4, minus 1.25. So the negative sign is shown as a deceleration. But the question asks me for the magnitude. So the only way you can get the second mark here is if your answer is not carrying a minus sign. Okay, so the magnitude of the deceleration is 1.25, and the units for that is meters per second squared. Now then, the part C, determine the distance between A and B. Now the distance is the area under the graph, and what I mean by that is, under the graph, there's the graph, I have to bring it all the way down to the time axis to get that area. Okay, and some of you missed that out, right? This part here, even though that line isn't coming down the axis, that rectangle in there is part of the distance travelled. I need that area as well. Okay, so to get the area, I've got this rectangle here, 18 by 48. I've got the triangle, 15 times 12 divided by 2. And I got this rectangle at the bottom here, which is a 12 by 3 rectangle. Those 3 sections make up the total distance travelled. Okay, and working those 3 separate parts out will come to a total of 990 meters.